In the ever-evolving field of electronics, acing an interview can be a daunting task. This video is specifically designed to guide you through the top 20 interview questions and provide comprehensive answers. From fundamental concepts to complex circuit analysis, this video covers a broad spectrum. It aims to equip you with the knowledge and confidence needed to impress any potential employer in the electronics industry. 1. What is the difference between analog and digital signals? Analog signals are continuous in nature and change smoothly over time. They can have any value within a specified range. For example, a sound wave is an analog signal as it can have infinite number of variations in amplitude and frequency. On the other hand, digital signals are discrete and can only take specific values. They represent information in binary format, i.e., ones and zeros. They are not affected by noise or distortion as much as analog signals, making them more reliable for transmitting data over long distances. In contrast to analog signals, digital ones are less susceptible to distortions and noise, making them more dependable for long-distance data transmission. They're represented in binary format, meaning they can only assume certain values. Analog signals, on the other hand, are continuous and smoothly fluctuate over time. They can assume any value within given boundaries. For instance, a sound wave, which can have an infinite number of amplitude and frequency variations, is an analog signal. 2. Explain Ohm's law and its applications in electronic circuits. Ohm's law states that current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points. It is integral to electronic circuits, as it allows us to determine one value when two are known. It offers a way to understand and calculate how currents, voltages, and resistances interact with each other. In terms of practical applications, Ohm's law is essential in designing and testing circuits. For instance, it helps in determining the right resistance needed to control the flow of current to a certain level or the amount of voltage needed to generate a certain current flow. It is also useful in troubleshooting circuits, as discrepancies between expected and measured values could indicate problems such as short circuits or component failures. Ohm's law is a fundamental principle within the field of electronics. It provides a mathematical relationship between voltage, current, and resistance in an electrical circuit, stating that the current is equal to the voltage divided by the resistance. This law is crucial for designing and understanding the functionality of electronic circuits. For example, it can be used to calculate the resistance required in a circuit to produce a desired current flow when a certain voltage is applied. Conversely, if the current and resistance are known, the voltage can be calculated. It's also valuable for troubleshooting, as inconsistencies between calculated and actual measurements can point to issues within the circuit. This law is the foundation for many electronic concepts and devices, making it indispensable in the field of electronics. 3. What are the basic types of logic gates and their functions? Logic gates are the building blocks of any digital system. They operate by using binary inputs to produce a binary output. There are 7 basic types: AND, OR, NOT, XOR, exclusive OR, NOR, not OR, NAND, not AND, and XNOR, exclusive NOR. The AND gate produces an output of 1 only if both its inputs are 1. The OR gate produces an output of 1 if at least one of its inputs is 1. The NOT gate, also known as an inverter, flips its input, turning a 1 into a 0 and vice versa. The XOR gate produces an output of 1 if its inputs are different. The NOR gate is the opposite of the OR gate, producing a 1 only if all its inputs are 0. The NAND gate is the opposite of the AND gate, producing a 0 only if all its inputs are 1. Lastly, the XNOR gate is the opposite of the XOR, producing a 1 only if all its inputs are the same. These gates are the foundation of digital electronics and are used to build more complex circuits and systems. 4. Describe the working principle of a transistor. A transistor is an essential electronic device that regulates current or voltage flow and acts as a switch or gate for electronic signals. The base current is the input, the collector-emitter current is the output, and the number of electrons able to cross the junction is the control. When a voltage is applied to the base, it changes the barrier height and width of the base-emitter junction, controlling the current that can flow from the emitter to the collector. There are 2 types of transistors: bipolar junction transistors, BJT, and field effect transistors, FET. Their function is essentially the same, However, they use different methods to control the electrical signal. 5. What is the purpose of a capacitor in an electronic circuit? A capacitor, in an electronic circuit, serves multiple functions. It primarily stores electrical energy and releases it when required, acting similar to a battery. This property is particularly useful in power supply circuits where they provide a reserve power source. Capacitors are also used for filtering. They can smooth out fluctuating signals or remove noise from signal lines. In coupling applications, they allow AC signals to pass but block DC in timing circuits. They are used in conjunction with resistors to create delays. In motor start circuits, they provide the initial jolt of current to start the motor. In short, a capacitor plays a versatile role in the functioning of electronic circuits. 6. How does an operational amplifier work? An operational amplifier, op-amp, is a crucial component in electronics. In an operational amplifier, the input signal is applied to the inverting, or non-inverting, plus input terminals. The op-amp amplifies the voltage difference between these two inputs, producing an output signal. This amplified output is dependent on the feedback configuration. If the feedback is from output to inverting input, negative feedback, the op-amp works as an amplifier with characteristics like gain stability and linearity. If the feedback is to the non-inverting input, positive feedback, the op-amp behaves as a comparator or oscillator. The operational amplifier has a high input and low output impedance, making it a versatile tool for various applications from audio and video processing to control systems and instrumentation. It's a valuable tool in the electronics field, known for its versatility and efficiency. 7. Describe the function of a multiplexer and demultiplexer. A multiplexer, often shortened to MUX, acts as a multiple input, single output switch. It directs binary information from any one of the multiple input lines to a single output line. Its function can be compared to that of a multi-position switch. A key role of a MUX in digital electronics is to save on wiring and to perform data routing. On the other hand, a demultiplexer, or demix, is the reverse of a MUX. It takes a single input line and routes it to one of multiple output lines. One can think of it as a single input, multiple output switch. It serves a vital function in applications where data from one source can be directed to multiple destinations. There are many practical applications of these devices in digital systems. For instance, in telecommunication networks, a MUX can be used to carry multiple signals over a single communication line, thereby reducing the overall cost. A demix, in contrast, can be used at the receiving end to split the signal back into the original channels. Additionally, these devices are also used in memory chips, CPUs, and data routing applications. 8. What is the purpose of a Schmitt trigger circuit? A Schmitt trigger circuit is a particular type of circuit used primarily in signal processing. Its primary function is to convert an analog input signal into a digital output signal. This is achieved by using a threshold or hysteresis value to determine when the output should change states. When the input signal exceeds the high threshold level, the output changes to a high state. Conversely, when the input falls below the low threshold level, the output reverts to a low state. This feature of the Schmitt trigger circuit helps to reduce noise and provide a clean, stable output signal. This is especially useful in applications where the input signal may be noisy or unstable, such as in sensor readings or unstable power supplies. 9. What tools and software do you use for circuit simulation and analysis? As an electronics engineer, I use numerous tools for circuit simulation and analysis. I utilize Multisim for circuit simulation because of its extensive range of components and its intuitive interface. For more complex simulations, I use SPICE, which offers detailed analyses of circuit performance. For PCB design and evaluation, I find KiCad and Eagle to be highly beneficial. Simulink is also handy for system-level simulation. For digital circuit simulation, I use Logisim as it allows me to design and test digital logic circuits. Lastly, for microcontroller simulation, I prefer Proteus due to its flexibility and wide range of supported devices. 10. Describe a challenging circuit design problem you've solved in the past. Previously, I was tasked with the design of a high-efficiency power supply for a portable device. The circuit had to operate under a wide range of conditions, including different power states and temperatures. The biggest challenge was to maintain high efficiency while keeping the size of the circuit small. To solve this, I used a combination of a switch-mode power supply, SMPS, and linear regulators. The SMPS was used for the high power load, while the linear regulators were used for the smaller loads. This design allowed us to achieve a high efficiency of over 90% under all operating conditions, while maintaining a small circuit footprint. Through this experience, I learned the importance of selecting the appropriate components and designing the circuit to meet specific requirements. 11. How do you ensure signal integrity in high-speed digital circuits? Signal integrity in high-speed digital circuits can be maintained through various strategies. One crucial method is to employ proper routing techniques. For instance, keeping traces as short as possible helps reduce signal degradation. Another essential strategy involves the use of termination resistors to avoid reflection. It's also essential to ensure that the power supply is stable, as fluctuations can cause signal distortion. Ground planes are used to minimize electromagnetic interference, which helps maintain signal integrity. Also, differential signaling can be used to reduce noise and maintain the quality of the signal. The use of quality materials for PCB and employing accurate impedance control are also vital in ensuring signal integrity. Regular testing and inspection of the circuits can help detect any issues early and rectify them, thus ensuring the integrity of signals. 12. What steps would you take to debug a malfunctioning electronic device? Firstly, I would gather as much information about the issue from the user, if possible. Understanding the problem and when it occurs can be very useful. Next, I would visually inspect the electronic device for any noticeable damage or issues, such as burnt components or loose connections. Following this, I would use different diagnostic tools, like an oscilloscope or a multimeter, to measure various parameters in the circuit. This helps in identifying any abnormal behavior or readings. If the issue is still not identified, I would check the software, if applicable, for any bugs or issues. It's essential to take a systematic approach and isolate different parts of the circuit or device to narrow down the issue. Finally, once the problem is identified, I would fix it and ensure that it's working properly before returning it to the user. 13. Explain the importance of EMC, EMI testing in electronic product development. The EMC, electromagnetic compatibility, and EMI, electromagnetic interference, testing play an essential role during development of electronic products. These tests help identify issues that might lead to the device malfunctioning when exposed to electromagnetic fields. EMC testing ensures that a device can operate properly in its intended environment without causing any unwanted electromagnetic disturbance. On the other hand, EMI testing evaluates how much of electromagnetic interference a device emits, potentially affecting other nearby electronics. Both tests are critical for maintaining device safety and reliability, and are often regulatory requirements in many industries. Now, imagine you are creating an innovative electronic device designed for widespread use. You want to ensure that it won't interfere with other devices or be affected by their emissions. EMC, EMI testing can guarantee that. It also helps ensure that your device meets all applicable regulatory standards, allowing for smoother market entry. Additionally, conducting this testing early in the development process can help identify and rectify any potential issues, saving time and resources in the long run. Therefore, EMC, EMI testing plays a significant role in the successful development and launch of any electronic product. 14. How do you use an oscilloscope to analyze circuit behavior? An oscilloscope is an essential tool for electronics engineers. It allows you to visualize the behavior of electrical signals in a circuit, which aids in troubleshooting and debugging. To use an oscilloscope, one must first connect the probes to the points in the circuit where the signal is to be measured. The oscilloscope displays the signal as a waveform on its screen, with the vertical axis representing voltage and the horizontal axis representing time. By adjusting the settings on the oscilloscope, you can change the scale of the waveform to better understand the characteristics of the signal. You can measure the peak-to-peak voltage, the frequency, the phase difference between two signals, and other parameters. An oscilloscope can also be used to capture transient events, detect noise, and investigate the performance of a circuit under different conditions. 15. What precautions do you take when working with high-voltage circuits? In handling high-voltage circuits, safety should be prioritized. One must wear protective gear like insulated gloves and safety glasses. Using tools with insulated handles is also crucial. It's important to always check if the circuit is de-energized before working on it by using a voltage detector. Keeping the work area clear of any conductive material can prevent accidental contact. Additionally, one should be knowledgeable about the circuit they are working on, understanding all components and their functions. Always following the manufacturer's instructions and safety guidelines is another key step. Regular maintenance and checks should be conducted to ensure the equipment is in good condition. 16. What emerging technologies in electronics are you most excited about? The field of electronics is constantly evolving, with new technologies emerging on a regular basis. I am particularly excited about the advancements in nanotechnology. This technology allows us to create smaller, more efficient components that can be used in a variety of applications, from medical devices to consumer electronics. Another exciting area is flexible electronics, which can be bent, rolled up, or even worn on the body. These could revolutionize everything from wearable devices to solar panels. Lastly, the intersection of AI and electronics is thrilling. With the aid of AI, electronics can become smarter, more adaptive, and more efficient, opening up many possibilities for new applications. 17. How do you stay updated with the latest developments in electronic engineering? In this rapidly evolving field of electronic engineering, it's vital to stay abreast of the latest developments. One way I do this is by regularly reading technical journals such as IEEE Spectrum and Electronics Weekly. These publications often feature articles on the most recent advancements and research in the field. I also attend webinars and online courses to further my knowledge and skills. Participating in online forums and communities of electronic engineers is another way I stay updated, as it allows me to engage in discussions and gain insights from peers around the world. Lastly, I follow relevant organizations and thought leaders on social media platforms, which is a quick and easy way to get updates on the latest trends and technologies. 18. What are the key considerations when designing for IoT applications? IoT, Internet of Things, reshapes the way we interact with our environment. Designing for IoT needs careful attention to various factors. Firstly, connectivity stands as a crucial aspect. The device should seamlessly connect to the Internet and other devices, considering various protocols and standards. Secondly, power management is vital as IoT devices often run on batteries and need to consume less power to increase lifespan. Another important factor is security. These devices often handle sensitive data and should be protected from potential threats. The device should be user-friendly and easy to install and use, enhancing user experience. It's also important to consider the physical durability of the device, as many IoT applications are used in harsh environments. The lifespan of the device and its components, and the maintenance requirements of the device over time, are also key considerations. The device should also be able to handle large volumes of data and have the ability to process and analyze this data effectively. The device should also be capable of interoperating with other devices and systems, and be flexible enough to adapt to new technologies and standards as they emerge. 19. How is AI impacting the field of electronics? AI, or artificial intelligence, is creating significant changes in the field of electronics. The introduction of AI has made devices smarter and more efficient. This technology now enables devices to learn from their environment and make decisions based on that data. For instance, AI is used in home automation systems to learn the user's habits and adjust the settings accordingly for optimal comfort and energy efficiency. Additionally, AI is used in predictive maintenance of electronic devices, reducing downtime and increasing lifespan. It can analyze data from sensors to predict potential faults or failures in advance, allowing for timely intervention. AI also aids in complex circuit design and simulation, reducing human effort and error. 20. What challenges do you foresee in the electronics industry in the coming years? In my perspective, one of the major challenges could be the rapid pace of technological advancements, which demands continuous learning and adapting. Keeping up with the latest tech trends and mastering new tools and techniques can be demanding. Another challenge could be the increasing complexity of electronic systems and circuits. As we strive to make devices more powerful and compact, the complexity of design and manufacturing processes is likely to rise. This calls for more sophisticated design tools and techniques. There's also the issue of environmental sustainability. With e-waste becoming a global concern, there's mounting pressure on the electronics industry to develop more environmentally friendly products and disposal methods. Lastly, security can be a key challenge. As more devices get connected to the internet, protecting them from cyber threats becomes increasingly difficult and important. We hope you found this information useful and it boosts your confidence in your electronics knowledge. If you appreciated this video, please hit the like button and consider subscribing to our channel for more insightful content. Your support keeps us motivated to create more such informative content. Remember, preparation is the key to success. Good luck.